everyone, my name is Debanjan Naskar and today I will cover a session on the advanced implementation of ROS2. This is a continuation of the previous session titled as Basics of ROS2 that I had covered. Let's see what we will learn today. So by the end of this session, we want to build a project. Here you can see I am launching some launch command using ROS2 launch. Okay, I'm typing some launch command and then I will press enter and what happens we will see. So after I hit enter, a 10 cross 10 grid appears and some boxes in this 10 cross 10 grid are colored sequentially. What does this mean? What does this project do? We will learn forwards. Okay, so project objective. In this project, we will have a 10 cross 10 matrix or 10 cross 10 grid, whatever you say. You can see clearly. Now we want to give the system some random points. So a custom message numbered 1 to 100 where point denoted as 15 refers to second row, fifth column and 82 refers to ninth row, second column. So let's understand this. Now we want to give the system some random points using custom message. What is a custom message? We will learn that. But for now, you can understand that there are 100 boxes, right? In 10 cross 10 grid, there are 100 points, coordinates, whatever you say. And then in that 1 to 100, each refers to one of those boxes. So somehow a message means a basic information. You are passing an information to the system that will contain a number from 1 to 100, where each of the number refers to a grid in the 10 cross 10 a grid box. Right. So next what happens after we have passed this box's number, the system then starts from 0 comma 0 of the grid and then goes to one random point after the another. So which random points that we have generated previously? This random points like 15, random points like 82. Okay, let's say where will be 15 here? This is 1, this is 10, this is 11, 12, 13, 14, 15. This is the 15th grade. Where will be 82? So 82 will be ninth row, 1, 2, 3, 4, 5, 6, 7, 8, 9. Ninth row, second column first, second. So 81 and this will be 82. So this is how it is denoted. And then these are the random points and the code starts from 0 comma 0. The system then starts from 0 comma 0 of the grid and they then goes to one random point after the another sequentially. The traversal of one point to another will be either through Dijkstra algorithm or A star algorithm. You can see the Dijkstra algorithm is a path planning algorithm and A star is also a path planning algorithm. So what is a path planning algorithm? Let's discuss it a little bit. So when in a coordinate system you have to go from one coordinate to another autonomously, you want a path planning algorithm. What it does is it analyzes somehow through the algorithm what is the shortest path or close to shortest path, the most efficient path to go from a point A to a point B. So this traversal from one point to another through either Dijkstra algorithm or A star algorithm will take place. If a point is reached from here to here, okay, this green box to this green box, the system is going. If it is using A star algorithm, then it will be covered in blue, and if it is using Dijkstra algorithm, then it will be covered in yellow. Like for example, from this green point to this green point, we are going through the Dijkstra path planning algorithm. So the path is covered by yellow and the final points are green. You can see the start final points and all the respective random final points we have sent are green here. We will configure this later in the code. You can then understand it more clearly. Okay. So after we have achieved all this random points we are sending. After the system has reached all of those, it shows a success message and then stops. Fine. So this is what we want to build. Now it comes to how, what we will use, and why are we doing it, right? What we will learn from this. So what we would learn from this project is action. Action is a communication interface built on top of topics and services. We will understand what this means. Custom message and service files, custom action files, how to build a action server client architecture, what is CMake lists and package XML, we will understand better. And then what are launch files, why are they necessary? And this last point, I will not cover much of it, but yes, a basic understanding of path planning algorithms and tkinter we will have. So starting with brief introduction about action. So previously we have seen that services and topics have very two different use cases, right? Services on one hand are one-time running tasks and always provide a response on a request, whereas topics are a continuous data outflow but don't have any such response to verify if our information has reached the subscriber effectively or not. So action solves this problem by building on top of services and topics. What does this mean? So actions extend services by allowing long running tasks with feedback and cancellation options. Right? We will see an example to understand this better. So when I run this, okay, one thing you can see is I am sending a goal and the action server is receiving the goal and providing feedback. Current position is 35, current position is 34, 33, 61, 8, 71, 81, and so on. So it is a long running task that is it is not stopping at once, and it is providing a feedback or response. That is what we lack in topics or services. So this combines the functionality of both, and that is why it is such a popular stream of data communication in a modern complex robotic system, right? Okay. So going back to an example, for example, a robot navigation node may expose an action, navigate to goal, where a client sends a goal location and continuously receives a feedback. So 20% completed, 50% completed. So feedback can be any type. We can see how to build our custom feedback, custom action messages. We'll see, but we can send response of any type, any data type. We can send request of any data type, and we can send feedback of any data type. And we can continue this until the task we have assigned has ended. So it combines both continuous data flow and the response system. So what will be the project architecture? If we see, this is a very high level project architecture that we are aiming to build. We will not start with this is not a top down approach. We will not start with launch file and then go to client service node. We will see how to develop, but this is a high level implementation. That is, we will start with a launch file. We will type ROS2 launch and some command that will open three of these nodes. The service node will be requested for some information by the client. Then the service node will give a response. Then this client will pass those response one by one to the server node, and the server node will provide some feedback. And after this feedback is completed, after this action we have designed has reached its goal, then we will send a result as in the form of result response. Right? Okay, let's now go to understand this more deeply how we will accomplish this. So you have seen that we have three main nodes. One is this grid service node, this action client node, and this action server node. Right. So the primary first starting point will be service node. What will this do? This has two main components, the custom message and custom service. So it will get a request from the client In the Boolean data type, the node waits for any request from a client node, which will be in Boolean type, and then it will return a response of the grids message type. What does this grids message type contain? It contains two lists of box and algo. What does this box and algo grids message do? So both of them are, you may say, arrays or lists. So on receiving the request, it sends two equal length Python lists, one containing the box numbers 1 to 100 to traverse, and other contains the algorithm to reach the box. So what does this mean? If we go to this slide, we will see that there are some numbers which are sent to this system to reach. We have to reach one, then we have to reach something like this will be the 17, if I'm not very wrong, or this will be the 18. So we have to reach one, we have to reach 18, then we have to reach 36. These are the point numbers. And what path planning algorithms are we using here? To reach from here to here, we are using A star. To reach from here to here, we are using Dijkstra, right? So the same thing, this both of these parameters are passed to the client as the form of response in the form of grids message that we have built. So obviously both of these Python list will be of the equal length, and one will contain the box numbers to traverse and other will contain the algorithm to reach these box numbers. Okay. So next, after my action client gets this uh, waypoints or these coordinates from the service node, what does it do? It sends, okay, maybe my camera is obstructing. Just wait a bit. We'll change that. Maybe a little bit more. Okay. So what does this client do now? The client then sends a request to the grid service, and this grid service turns the in turn sends this node to Python list as we have discussed, right? So after that, the client node then wait for the action server to send each element of this Python list one by one. So it sends each of this coordinate one by one, and then the action server sends this client node feedback. Okay, I am reaching this point, then I am reaching this point, and eventually it will reach the goal that the client has sent to the server, right? So after the execution of one goal, the other goal is then next being sent. At the end of each goal, the client gets a new result which contains the path length. Here it is written path length. So if you see here, I will show you. Just wait a bit. Yes. So if you see here, after each point we are reaching, sending goal 36, and then after reaching here, a message is being sent to the client titled as path length for reaching that point is 4. So we have to cover 4 grids to reach that path. So to reach that point through the path, right? So this is the result that our client is getting from the action server. Okay, fine. Next, so what does this server do? After receiving the point from the client, the server then initializes a tick enter window. What is tick window? We will see. So it opens a tick enter window for building the 10 cross 10 grid. And then the action server, what does it then takes a goal from the action client and then goes to the goal from its current position with the help of a path planning algorithm, which will either be Dijkstra or Ester. At the end of the uh, execution, it sends this path link. You can see very nicely here is the custom action file that we will build. It contains a integer array of length 2, which contains a target. So this target, what will this target contain? This target will contain both the point we have to reach and how will we reach. The choice of our path planning algorithm will be contained in this target. Then there will be the path length will be the result, and the feedback will be the position that what is my current position after each time our system changes the position from one grid to another, it will send that to the client as a feedback, right? Fine. Now launch file. I will discuss launch file later. This is just an introduction. So ROS to launch file, what it does is now we have three nodes, right? Effectively, we have service node, we have action node, and we have client node. Sorry, I have service node, I have client node, and a server node. To accommodate this whole program, what we have to do is run each of these nodes separately. We will first open a separate terminal and type ROS to run the service node, a separate terminal ROS to run the client node, a separate terminal and ROS to run this server node. So what this launch file does is, if we just type ROS to launch the package name and the launch file name, it can open all of these nodes simultaneously at once. This saves a lot of effort. So this is what is our architecture will be. Now we will discuss next the components. So to discuss the components, I will just read out the basic definition, try to understand, and then show the actual component that we have used in this project. Okay, what does that mean? So, for example, for custom message file, we will try to understand what it means. In ROS2, a custom message file is used when the built-in message are not sufficient. For example, if a robot needs to transmit both temperature, humidity, and a status flag in one message, how to do it? Here comes the implementation of custom message. In the same way, our custom message sends two equivalent length arrays, which are box and algorithm. In this session, I will not code everything from top to the like from scratch, but I will show you the code and explain everything in detail. Okay. So let's go to our VS Code and see what it means. Okay. So this is our workspace named Action Workspace. And if I go into it, there are two files. There is one source and there are two packages, custom and project LG. So there are two packages. Now, if I open the project LG package, I will see there is a source, and in the source, these nodes are here. And the project LG also contains the launch file. Now, what does this other package contain? The custom. Here we contain the custom action, custom message, custom SRV. So it is very important that you make this folder inside a separate package, and then all of the names of this message or service file that you give should start with a capital letter. Here the G is capital, here the E is capital, right? Here the G is capital. So this grids.message will contain this int32 box array and this int32 algo array. So this is how we have made the custom message inside the custom package. And inside the custom package, we have made a folder named message, and inside this, there is this file. In similar way, we will see what is custom service. So service has two major components. One is the request type and other is the response type. So you could have seen that in Spawn, for example, in Spawn, in turtles in Spawn, what is the request type? The request type is we give it X, Y, theta, and the name of the turtle. And in response, it only sends us the name of the turtle, right? So similar way in service file, we can regulate whatever request we will accept and whatever response we will give out. So service file is used when a robot needs a request response interaction with the data types that are not covered by standard ROS2 services. How to do this? Let's see. So in this custom package in SRV file, in SRV folder, there is this service file. And what does it contain? It contains this request. So we are saying that we want the request in the Boolean data type and we want the response to be in grids data type. And what is this grids data type? The grids data type is this message data type, that grids.message that we have created earlier, right? So this is how we will design the service. Fine. Now going forward to the action files. So action has three components. See, in message there was only one block. In service there are two blocks, a request and a response. Our action has three blocks. One is of goal, second is of feedback, and third is of result. So how is it designed? So okay, let's first read it. A custom action file is used when a task requires goal, execution, goal feedback, and a final result, such as robot navigation or arm movement. So, unlike services, actions also allow continuous progress updates in the form of feedback and can be cancelled mid task. Okay, so let's see. Inside this custom, there is an action package. Okay, there is an action folder inside this custom package. And in this action folder, there is this action file named explore grids.action. So in this explore grids.action, there is the goal, there is the result, and there is the feedback. So I want the goal to be a array of two dimension. The path length should just be an integer and the position should just be an integer. So this is what will happen. Okay. So for defining such a custom package, what do we need to add in the CMake and package XML? CMake list and package XML. We will see that now. So in this custom package, in this CMake list, we have to add this additional commands, that is ROS, IDL, default generators and built-in interfaces. Okay. And this is the additional message grids message generate interface, service generate interface, and action generate interface. So we have to write a ROS IDL generate interface and then wrap up all these three inside this. And this is how we will successfully build all these custom message, custom service, and custom action files. Fine. We will now go towards path planning algorithms. Okay. So path planning algorithm is the part that we will focus the least in today's session. So there are two path planning algorithms that we have used named Dijkstra and A star, and these are used for general path planning also. There are the Dijkstra algorithm finds the shortest path always by exploring all possible routes. It somehow explores all possible grids after going to a before going to a particular grid. So it will explore the shortest path, but A star improves the speed by using a heuristic function to prioritize paths. What does this mean? Is that A star uses a function that measures the length remaining from the goal and behaves a certain way when the length increases or decreases. Okay. So somehow A star is faster, but Dijkstra is more accurate. But in this, a small 10 cross 10 grid, both are exactly same. Uh, both are acting exactly same. So next, Tkinter. Tkinter is a Python's built-in graphic user interface tool. This provides some basic desktop app building qualities, and where we can add some interacting interfaces like buttons, labels, text fields, and canvases. Here we have used a 10 cross 10 grid with the help of Tkinter only. So Tkinter is widely used for simple graphical user interface tools, and I thought this is the best thing, and this is the most simplest thing I can go with for this project. Okay. So last but not least, configuring CMake list and package XML. So most probably I missed the package XML of this custom package. So in this package XML, you have to also add this code lines, build tool depend, ROS ideal. You can see that, and these are all taken from the general documentation of ROS to Humble. This documentation is very helpful. I would recommend whenever you get stuck on a concept, please look here. And this have all the commands that you have to add to this package XML or CMake.list, for example, here you can see. So like this package XML and the previous was CMake list. So this contains all of these things. Fine. So now going towards what does this do? Okay. So there are two types of build tools available to us in ROS2. One is the Python build tool and the other is the CMake.list build tool, which is more based on C. Okay. How would you understand this? You will go here, creating a package, and here the documentation shows you two ways, the CMake and the Python. So I generally use the CMake list because I think it is much less crowded and it's the repository looks much cleaner, but you can use Python if you want to. How can you create a package using, if you don't type anything regarding which build tool you intend to use, the package will be built using CMake only. So how to build the package? You will go here in source, open terminal, and just type this ROS2 pkg create any let's say build testing. Our package name is build testing. So something opens as build testing package, and this has CMake list and package XML. So this is made using the CMake. For now, we will delete this. We don't need it. So this is how the CMake list work. And in ROS2, the CMake list and package XML define how the package is built and described. Although Python packages don't require compilation, CMake list is still used to specify dependencies. So you have to still mention the dependencies that your file has to CMake list and package XML. All right. Now let's code it. We have two package. One is custom package, one is project liquid galaxy package. So in this custom package, we contain all of this custom message, custom service, custom actions that we have already seen. Now the last bit, we will see how is this service client server and launch working. Okay, fine. So this is the last slide and we will discuss how the project LG package. This is the more important package in this project. So let's see how does it work. If you go here, you will see. Okay. So if you go here, you will see service. Okay, sorry. Yeah. So service contains all of these coordinates and all of this algorithm. So we are effectively telling the program to go to zero from 0 to 18 using the first path planning algorithm, then 18 to 36 using the second path planning algorithm, then 36 to 81 using the first path planning algorithm, and that is how it follows. Right? So how is this service defined? We create a node and then name our service something, then name the node something, and then name our service something, and we want to see what this service is, of which type is the service. So our service will be of get grids type, which we have already defined here, get grids.srv. Now we will create a service of the get grids type and then give the grids request two parameters, right? So no, the grids request will be one parameter named the boolean. So it will take, if the request.getGrids is true, it will process a response. How the response processed? The response is processed with the help of grids messages. So grids message, what is grids message? How does it come in? So grid message is a type of message from grids, and grids is taken from this grids.message. So grid message.box, because grids contain a parameter called box, should have uh, array, and grid message.algo should have an array, right? And then this combines the response and sends this response. So after it sends this response, the client gathers the response or collects the response from it, Basically, the clients first send the request to the service, and then the service sends the response, which the client then subscribe or takes it. Now, is this client written? The client is a node, and the node is named as this, and it is also a service client of this Grid Grids service, and it is also an action client of this Explore Grids action. So both of this, if you see, both of this will have the Explore Grids uh, type, which is defined here, explore grids dot action, and this get grids type, which is defined in this service type. Fine. So the first thing that comes to us is we will see if the get grids client is ready. If it is ready, it can have a callback from the service, and then it will contain all of this service in a self.coordinates list that I have created here. The self.coordinate list will append one by one all the responses and then sends this goal. So what does this send goals function do? Send goal then goes to connect to the server and one by one keeps on sending the targets and receives the feedback. So when it receives the feedback, it shows current position is the feedback, and after the feedback it says goal, my goal is my path length for processing this goal is this result. Fine. And what does this grid server do? So the grid server has two algorithms, A star and Dijkstra. So whenever we hit a callback, we go to Python node, sorry, pathfinding app node, and from the node we create a tick enter canvas. Now after creating a tick enter canvas, what we do is we see if we open our explore grids action server. See, we are creating a action server. Self.action server is action server, in bracket self comma explore grids comma explore grids is the name of the service we are transmitting from here, right? From the explore grids, and it is of the type explore grids, which comes from explore grids.action. So if we hit a request, we will hit a callback also. This callback will take the goal, and from the goal, if the algorithm is one, then go from the start position to the target position using A star. And if the algorithm is two, it will go from the start position to the target position using Dijkstra. Fine. Then after it constitutes the path, the tick enter will open, and the system will go from one grid to another, and every position it goes, it would send a feedback here. Goal handle dot publish feedback and feedback message. So what does this feedback message contain? Feedback message would contain its position. So feedback message contains position. Why? If you see here in grids action, the feedback message, the feedback is said to have the name position. So in the position, it will configure as this is my current position, and it will publish the feedback. And after the whole thing is completed, a result will be initialized, and in that result, the length of the list path will be stored, and then the result will be sent. Okay, in the main of the server, this is a bit interesting. In the main of the server, the root title, that is the tick enter title, will be pathfinding.grid that we have seen already here. See, this is pathfinding grid. So that will be the pathfinding grid, and we initialize the RCL pipe, and then we initialize the node. Okay, very usual up to now. But after this, we have to process the tick enter also and the RCL pi also, and both of them are continuous. So we have to multi-thread them by some way, and this kind of achieves the same function, s- same implementation. So root after zero, we spin after every 0 seconds. So it is kind of simultaneous to whenever the root main loop works, but it is also different because both are running in different threads. And whenever the program is executed fully, we tell it push shutdown. So this is how the whole flow of the program goes. And I'll go and just go to this workspace and run a build command. After running the build, I have to now launch each of this node one after another like this. First to run grid service dot py. And my service is running. Okay, sorry, I have not mentioned the package name. We have to so mention the package name. Okay, it is running. Right? We have to also go in this and then say ROS2 run project LG grid client dot py. It gets all of this coordinates and the algo array, and then it is waiting for sending this column. Then what I have to do, I have also required to open the server. So ROS to run project LG grid server dot py. And this is when the code will run properly. So to avoid this, what I can do is I can design a launch file. I can design a launch file which launches all of these nodes all at once. And how to do that? You have to come here in Project LG or any uh, package where you have the important nodes. And you can also do that outside of this package. There is no problem. But I prefer it to do it this way. And you come here and then create a separate folder called launch. And then in this, create this file, a Python file named final launch or any name you will wish to give. But this has to be Python for now because I am teaching the Python way right now. So this is how from launch you have to import launch description, and from launch.ros actions you have to import node. Then you can launch each of these nodes at once. So what I am launching here, I am launching from package row project LG. You have to launch this grid service.py with name execution, and from package project LG you have to again run something known as the executable, and from the package project LG you have to always also run a executable named as grid server. Okay, so I will save this and see what happens if I now close all of this, and I will go to Shem and pull some build. Once this build is done, I will go and write this cross to launch. Which package are you located in, and what is your file name? Okay, sorry, I missed the dot here. And this will run this. And you can also exit midway. What does that mean? See, I just exited midway. This is the advantage of action, right? Okay. So how to configure the CMake list and project LG and the package XML for containing a launch file in CMake list. You have to do this RCLPy and custom because you are using custom messages in your source files. And for install, you have to write this. For launch file, you have to write this launch in destination this. Okay. And for package XML, you have to depend on this both the custom package and the RCLPy package. And then you are all set to go and run this program. And that is how I built my project. It was really fun to discuss it with you. Thank you. My name is Debanjan Naskar.